Take about one more minute and then we'll go over this. Oh my gosh. So blind now. Okay, turn to your partner and see if you know how to do them. Don't turn. You want to? You can ignore me all hour and do it. Air ball. Okay. So unless you get your hair braided, that's fine. But the rest of us, how do we feel about this? So give me 5 fingers if you think you can do all 5 of them. Down to 0 if you think you can do none of them. 2. Is that the ones that are in words?
Oh, I didn't even see those ones. I could maybe do them.
All right. I'll go through them quick because we spent a lot of time on it. Please. Okay, number 1 is H2SO3. Oh, let's see here. You don't, Tiffany, you don't ever have to turn this thing off. It just goes to sleep. Okay, that's fine. Oh, hey, welcome back. Okay, here we go. Acid, acid, acid. My turn to talk. Thank you, though. They're all acids because they start with H and they're not water. What's the name of this thing right here? Sulfite. ITEs become what? All right. So it's not hypo or hyper. It's just sulfite, right? So no prefix. So just sulfurous acid. Who had it right? Don't fight. Who had it right? Okay, good. HBr. Please don't talk. HBr. It's an acid. What's the name of Br? Bromine, which becomes bromide. Ide becomes ic acid. But we also must have hydro. Sorry, that should be up here farther, but whatever. Hydro bromic acid. Who had that one right? Gosh. Okay, good. Hydrobromic. It only has a hydro because it only has 2 types of atoms. All right, number 23, or the third one, it's an acid. NO3 is called nitrate. 8s become ic acid. So we have nitrate, so nitric acid. Who had that one right? Okay. Phosphorus acid. OUS meant it came from what ending? It means it comes from ITE, which means it's 1 less than what phosphate usually is, and that is PO4, so it's 1 less than that. So it'd be PO3. I know it's an acid, so I put an H here. And then I have to balance charges. +1 minus 3 H3PO4. There's a lot to it. There's a lot involved there. All right, hydro, I usually like these. If I see hydro, I know it's just H and then whatever element's left, S. I have to balance charges though. This is a +1, S is -2, H2S. How many smelled the PE hall yesterday? This substance right here, this was the majority of what you were smelling. Now I gotta be careful. We're calling this hydrosulfuric acid, but this is also hydrogen sulfide gas or dihydrogen sulfide gas. And that's the smell of poop. All right, methane too, but methane doesn't necessarily have a smell. So anyway, what? Why did they do it? They were trying to fix the sewer. So they had to take the cap off the main sewer for the whole school.
So what happened?
I'm not at liberty to tell you. Probably something the cross country team did.
Hey, after a run, we came to throw it.
That was the cutest thing Tim ever said. All right. Shh. What do you got? I got you. Why can't I kill it? Okay, I'm just grabbing it for you. Oh, come here. Why? You're in trouble, Brown. I tried. I tried to be humane, and now look at our problem. I think it climbed inside your shoe. Okay, besides the bug, focus. We're done with chapter 2. It's a chapter 2 and 3 test. So we're done with the easier of the two of them. Okay, so will you look through your notes while I open up chapter 3? And for about 1 minute, try and think about all the things we covered in chapter 2. There was some stuff at the start that wasn't that important to your test score. That doesn't mean it wasn't important to like science, but the AP test is not going to test you on the parts of the atom. All right. Then we spent a lot of time on some other stuff. Will you talk and see what did I really learn in chapter 2? Now I'll get chapter 3 going here. Just all of chapter 2 on the website.
And the different ways to separate. What is that? Like filtration. Separate filtration.
All right. So, chapter 3 and chapter 4 are probably my very favorites, which I will say that a lot, actually. And I will also say like chapter 11 and chapter 13 are my least favorite, probably. But I don't know. I hated math in school until I took physics, and then it gave math like completely a point. I was like, oh, math actually describes our physical world. Chapter 3 and chapter 4 are math. Now, they may not feel like it at first. That's what actually makes it kind of hard, because it's chemistry first and then math once you've done that. Most of you are okay at math. If you can add, subtract, multiply, or divide, raise your hands. Okay, that's all we're doing. But first you got to do chemistry to know what to add together, how to multiply it so you get the right stuff, and then divide as well. So it can be hard. Please stick with the pace and we'll be all right. All right, so anyway, chapter 3, that word is called stoichiometry. That's Latin for super fun time with math. Oh, wow. All right. Most people don't speak Latin anymore, but I do. I'm very, I was trying to pig Latin it, but I can't. I don't know. I can't even remember. Moving on. Here we go. So there's going to be a lot of words, and eventually we'll do math. We may not even get to mass today. Here we are. Has anyone heard of the law of conservation of matter or mass? What's that? The first law of thermodynamics is like this. You just change a word that's called energy instead of mass. So it's a lot more complicated when you read it. We may lay it down as an incontestable axiom that in all the operations of art and nature, nothing is created. And an equal amount of matter exists before, both, and after the experiment. Upon this principle, the whole art of performing chemical experiments depends. Thank you, Antoine Lavoisier. What we're really saying is that the amount of stuff you start with is equal to the amount of stuff you end with. That's the law of conservation of matter. Now, I've foreshadowed this. We've said it a few times that we have to balance chemical equations. We have to make sure the amount of atoms, amount of type and number of atoms is the same on both sides. Okay, we are going to rely on this for this entire chapter. This used to scroll just fine, but it really isn't. So another way of saying it, and I don't know if I already did or not in this class, excuse me, but the mass of products or the mass at the end must be equal to the mass of reactants or the mass at the start. Have I defined reactants and products already? Okay, because that's fundamental, like keyword number one. All right, next. So, whoa, look at that. Did I really cover 2 slides total from here to here? I must have. Okay, so we are already into what we call balancing chemical reactions. This goes super fast for some kids, and they have no idea how someone else doesn't understand it. And then it never clicks for some kids, and they hate, like, why is everyone bullying me? I don't get it. Okay, you're somewhere between that continuum. Be patient if you don't get it at first. Very few people never get it. But anyway, here we go. So here are a bunch of examples of equations we are going to balance. Balancing equations is a gigantic, important concept to learn in any chemistry class, especially AP. Balancing is based on the law of conservation of matter, that everything on the left must be equal to everything on the right. So matter doesn't get created or destroyed, it just changes forms. So here we go. What you should write down is Al2O3 and then an arrow. I'll write it here bigger. So Al2O3 and then an arrow. And this substance is decomposing into Al plus O2. Now, based on what we've spent the last 3 or 4 days on, you should be able to do this from words. If it said aluminum oxide decomposes into aluminum and oxygen, you should be able to write that exact same thing. Right? That's the level you need to be at really by today, but you probably aren't yet. So practice, practice, practice. All right, let's do that real fast. Tell your partner where this 2 came from, besides that I wrote it there. And then your partner needs to tell you where this 3 came from. Ready, go. Do you know either one, Keely? Right. So why is aluminum a 2? Why is aluminum a 2? Do you remember? It's because oxygen charges a 2, and we drop them and swap them. All right, here we go. Okay. Oh, come on. There we are. So we have the 2 is here to tell me there's 2 aluminums, right? That's an answer. The 2 is here because it's the same as the charge of oxygen. That's an answer. The 2 is here to balance out the charges of oxygen and aluminum. That's a great answer. All of them are fine, but this is what I'm looking for. Every time we put an ionic compound together, the charges have to add 0. So we drop and swap to do that. Okay, now I have a question. Do those two have the same reason for existing? Good. They are not there for the same reason. Why is this 2 here? All right, good. Oxygen needs a buddy. It means it's diatomic. So from a sentence, if you saw the words hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, let's skip any of them. Nope. Then when you wrote the symbol, you'd put a 2. Those are the diatomics. So why did aluminum not get a 2? Because I didn't just say it was a diatomic. So it's okay existing by itself. Fair enough? Okay. So now let's talk about the actual process we're here for, which is balancing, which means I'm making my arrow become an equal sign. Okay with that? Now, I got to be careful, and please watch the screen for a second. These numbers right here, they exist to balance charges. And you must balance charges before you put the numbers that we're going to put right here, because they are there to balance the reaction. It's kind of tricky because the word balance is used twice, and it sort of means 2 different things. We need to find the correct formula of these, if it's given to you in words, first by balancing charges. And then we come along and balance the reaction by changing the numbers in front. Okay, here's a vocab word. You don't have to write it, but I will use it a ton. The numbers that we put in front of things are called coefficients. Coefficients. I'm not sure that's spelled right, but you know me, I don't care.
Add a Q in there too.
All right, so coefficients. Coefficients tell me how many, I'm going to write this down. Thank you, my man. Pass that back to Alyssa Allen. Right there. Oh, okay. All right. Coefficients are numbers I'm going to put in front of something that tell me how many of them that there are. They do not change the formula though. So for instance, if I have a recipe to make cookies and it says 2 eggs or 1 egg, it's just telling me the amount of eggs, but it didn't just suddenly change to vegetable oil because I put a number in front of it. Okay with that? What we're doing is we're making the recipes so everything equals each other. And I can change the amount of stuff, but I can't just change the flour. It's like you need 2 cups of flour. You're like, oh, I don't have that. I'll put in 2 cups of sugar. Well, that doesn't work, okay? We can change the amount of stuff, but we can't change the stuff. So when you go to balance, don't change these lower numbers. You can only change how many of them there are. Okay, are we ready? All right, you do not have to write these down, but this is kind of the pattern I will follow. I will just go in order as I look at these. And I'll say, start with the highest subscript that is not part of a polyatomic ion. Let me, you're like, man, I'm sick of this slide. These yellow things, that was supposed to be yellow because I meant it to be. The yellow things, they are called subscripts. Okay, that's going to be a P. That's a D. My life is a disaster today. Okay. Subscripts are the numbers below. Coefficients are the numbers in front. All right. So what I mean by this sentence, I look at all of these and I look that I have a 2 here, I have a 3 here, and a 2 here. Now, these things right here, these are not rules. You do not have to do those things on the right side to get this right. Those have a name. It's kind of hard to find their name in the book. They're called Tom Davidson's Time-Saving Tips to Save You Time Tips. Now, in that extremely eloquent, concise way of describing or naming that, I mean, did it say you must do these to get it right? No, they are from my 19 years of teaching this stuff. They're my ideas that help you save some time. Like, I don't even know where to start. Well, I'm Tom Davidson, Time-Saving Tip to Save You Time Tip says you find the highest subscript that's not in a polyatomic ion. And I know I'm taking 20 minutes to balance one equation, but let's talk about what a subscript that is in a polyatomic ion. Just for a second, go with me here. If I have Na2CO3, this is a fundamental concept here. This 2 is not part of a polyatomic ion. This 3 is part of a polyatomic ion. This is telling me 2 sodiums are with 1 carbonate. And I should know carbonate because I memorized it 25 years ago. You should know it because you memorized it over the last 5 or 6 days. Right? Okay, now this would be incorrect, but if I had a 3 here, not part of a polyatomic ion. Okay, so coming back, looking at number 1, Al2O3 goes to Al plus O2. Is there even a polyatomic in that whole thing? No. So I start with the highest subscript. I have a 2, a 3, and a 2. So what one's the biggest one? The 3. So where am I going to start? The 3. Do you have to? No, you can start with aluminum, fix it, go back and fix the O, and then erase what you did with aluminum. You can do it, but start with the highest one. Okay, now this one that sounds like I wrote it when I was drunk right here, this is actually really helpful if you understand it. It says, if you see a 3 and 2, you should use the swaparoo. All right? You had me before. You know it helps, right? If you see a 3 and 2, you should do the swaparoo. I could rewrite this, but it wouldn't rhyme. If you see an odd and even, you should switch the even and odd. That's really what it's saying. And follow my logic here. For a second, you're like, gosh, dang, we can just balance the stupid thing. But I have to make a 2 equal a 3. They don't. But if I take a 3 and put it in front of the 2, and the 2 and put it in front of the 3, do they now equal each other? They both equal 6. So if you see a 3 and 2, you should do the swaparoo. What I mean by that, right here, I see a 2 and a 3, and now tell your partner something. Say, it has to be on the same substance, same atom. Has to be on the same atom or same polyatomic ion. Okay, so this is what I do. Are we ready for mind blowage? Here we go. We take the 3, which is like right here, and we put it in front of the thing that had the 2. Yeah, brain matter all over the room. All right, then what do I do with this 2? I can't drop it in there. That's changing the formula. It's okay. I wanted someone to say that. So thank you for remembering that I told you to do that today. You're perfect. Thank you. All right. Please do not ever sandwich something in here because that messes with the formula. All right. It goes here. Now, How many of you have ever had a parent say, well, you got to suffer the consequences of your actions or anything like that? I guarantee Davis Nelson's heard that before. That is, all right. So balancing, we start with the highest thing, we fix it, and then we deal with everything we just screwed up. That's life. So look right here. That 2 made 6 oxygens. That 3 made 6 oxygens. I'm feeling fantastic, but I have the aluminum still to fix, correct? Well, tell your partner how many aluminums are right here. 4. How many aluminums are right here? 1. I will need 4. There's only 1 right now, right? So what do I drop right there? Of 4. And then it's balanced. I have the same amount of every single thing on both sides of the arrow. How fun was that? I agree. Hold on. I'll get back there, whoever just asked me to do that. What I really want to do first, though, I'm going to draw this out as fast as I can. I have 2 ALs bonded to 3 Os, but I have 2 of that whole thing, right? You with me? You don't have to draw this, but hopefully you'll see it. AL, AL, O, O, O. And I have that 2 times. So I have AL, O, 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 AL. Then I have an arrow. How many aluminums did I have? How many oxygens did I have? Careful. I had 6. I have 3 groups of 2. Now, let's just highlight them quick. We'll go yellow for aluminum. 1, 2, 3. Don't know why I did it that way. 4. On the left. 1, 2, 3, 4 on the right. Let's go to oxygens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, whatever, 5, 6. This job's harder than it looks. It's equal. Each color has the same amount on both sides of the arrow. Fair enough? Good. We spent 15 minutes talking about an extremely easy one to balance. Yeah. I hear chairs moving. That's bad. Okay. plus HNO3 goes to MgNO3 plus H2. In sentence version, that would say magnesium plus nitric acid goes to magnesium nitrate and hydrogen gas. Do you need that larger? Can you see it all the way? You need it bigger? Okay. I don't know how much bigger I can get this, but I will do my best. It's locked, of course. Okay, fine. It's like the story of my life. I start off feeling all great about myself, and then I run out of time and it's all squished in. Okay, my friends, going back to the first rule, it says well, where do you start? I start with the biggest number, not part of a polyatomic ion. Does this problem actually have a polyatomic ion? Yes, it does, right here, right? Oh, that's a terrible combination. This will be uglier even probably, oh well. So what I mean by that first sentence is don't start with that 3. In fact, NO3 is together on both sides. So why even worry about NO3, like breaking the 3 apart? We are only going to worry about what numbers? The 2s. If they're the same, it doesn't matter. Pick one and go with it. So which one do you want to start with? Hydrogen. There are 2 hydrogens on the right. How many are there right here? 1. So I must double the amount of nitric acid in my recipe. Are we okay with that? Okay, now there's consequences to that action. By doubling H, I also did what? Doubled the NO3. But look right here. How many did I need? I needed 2. Oh, so now listen, we've balanced H and we balanced NO3. Have we balanced Mg? All right. Technically, we didn't do anything, and technically, we don't have to. There's one of them and one of them. Please look at me. Please look at me. Please look. This only applies to the things inside the parentheses. This 3 only applies to the thing it's next to. So does MG have anything?
No.
No, it's just a 1. A lot of times kids think the 2 goes to all of it. It doesn't. Just what's inside the parentheses. It's like math. If you had 3 times 2 plus 6 squared, you square 8 and then multiply it by 3, right? You don't square all of it. That just applies to what's in the parentheses. Okay, number 3. I will write it out. K plus HOH goes to KOH plus H2. If I was good at drawing a skull and crossbones, I would draw it on that flag. That's a red flag. What are red flags? They're warnings. They're things that kids screw up on, and it's water. You're like, it's water. I want to show you how you screw up on water. If this is written out as K plus H2O goes to KOH plus H2, it's a million times harder to balance. A lot harder, a lot more landmines. So here is my extreme strong recommendation, and it's typed right here. Write water as HOH if OH minus is on the other side of the arrow. It will save you so much wrongness and save you so much time. I know my English is not very good. All right, write water as HOH if OH is on the other side of the arrow. And what I'm about to say, kids don't like it, but I don't care. I'm a beautiful man. So what could hurt me? Just kidding. Lots of things could, but I'm not really good looking. All right, here we go. This is what I'm going to say. Your whole life, you've sort of been lied to. There are not 2 H's in water. There is 1 H, and it is right here. And there is 1 OH, and it's right here. It's important when you see a problem with OH in it that you realize there's not 2 H's in water. There's 1 H and 1 OH polyatomic ion. Now, this only matters if OH is on the other side in water, which it is. Okay, follow me here then. What's the highest subscript? This 2. So please, this is where you get all annoyed. There's only 1 H here. So what must I do? I have to double the amount of water in my recipe. Now, it doesn't eliminate H, but I'm going to pretend H isn't there now, just for balancing purposes. How many OHs did that make then? 2. So what do I got to do over here? Do I go like this? No, that's called the backhand rule. That means if you do it, I get to hit you. We can't change formulas. We can change the recipe is all. So I put a 2 right here, right? And that takes care of OH, but what's left now? It made 2 Ks. So what do I need right here? A 2. And then I come back to where I started. Did any other thing change the amount of H's? Nope. So I just put a 1. And yes, you should put a 1 if it's a 1. I know like naming, we don't, but in balancing, we do. Because you get credit for that answer right there. If you just leave it blank, they don't give you credit for it. Okay. Now, if you write the equation, K plus H2O goes to KOH plus H2, you think like, oh, 2 H's, 2 H's, what the? You're in trouble because there's 3 H's over here and there's only 2 over here. And you're like, I don't know what to do. This class sucks. Okay. Now, there's plenty of you that can figure that out, but it's a lot easier if you do it the other way around. Okay. Now, look at number 4. C6, H6, O2, CO2, H2O. Look at right here. This is HOH. This is H2O. Is Davidson a liar? No, it's not on the other side. There's no value in this writing water as HOH. It won't matter ultimately. You can do it the same way, but it really is a big if right here. Okay. Number 4 is a combustion problem, and you'll learn how to know that. Balancing combustion reactions can be super hard, or if you just follow what I tell you, they're extremely simple. Okay, so here we go. I will rewrite it. It is C6H6 plus O2 goes to CO2 and H2O. This is a combustion reaction. In a combustion reaction in chemistry, it means we're burning a hydrocarbon. There's more definitions of it, but that's what that means. Are we out of here in 20 seconds? We are? Okay, watch for a second. We'll go over it. But you start with a 2, you balance carbons. You take the number with 6, put it in front of water, then you balance your oxygens. 12 times 2 is 24, plus 6 is 30, divided in half, and you get a 15. All right? Now, I don't think you followed that, and it's okay. I will go over it. These are hard, but we'll make them your strength. Okay? The bell hasn't rung yet. Are you sure we're out at 15? 12:20. Okay, so here we go. My bad. Let's do this. Let me write out the rules of what I just did. Start at the front with a 2. There's 4 steps here. If you follow them in order and do exactly what I say, there's only one thing you ever have to even think about when you do this. And it's not that one. What do I mean by start with a 2 at the front? I mean, I literally put a 2 at the very front. I double the hydrocarbon. Okay. Number next, balance carbon. Okay, so what do I mean by balanced carbons? I just put a 2 here, which means I now have 2 times 6, which is 12. So I go over and put a 12 in front of CO2. Let's remind ourselves, this 2 only applies to the O, correct? Not the C. All right, the next step is to, this one requires no brain power, it takes more work to write it. Take the number with H, which I mean this number right here, and put it in front of water. Now, so far, we have 3 things in Addie's life. WTH are we doing? Well, you're doing things because I told you to for right now. The because. It works out magic in the end. All right, here we go. Next. The 4th step is the only one that requires much brain power, and that is to balance oxygen. Okay, now, watch how I did it. I did it super fast because I thought we were leaving, but I'll do it again. I started with the 2 at the front. I instantly knew that meant I had 12 carbons. So I put a 12 in front of CO2. The next step said, take this number and put it in front of water because I told you to. Don't think, just do. Kids really screw this up if you think it through. This is what you'll do if you think. You'll see a 6, you'll see a 2, and you're like, I need to multiply it by 3 to get 6. But you don't, because you put a 2 there. Whatever. Okay, then the last part, the only thinking part, every number would already be filled in except oxygen. So the last step is to balance oxygen. So you have 12 times 2 oxygens here. You with me? That's 24. But there's 6 times 1 more of them, right? So 24 plus 6 equals 30. Now time out. There's 30 on the right, but whatever I put here will be doubled. So that's why it became a 15. Okay, I have a minute. I'm going to do one more real quick, and it's gasoline. C8H18 plus CO2 goes to H2O. Sorry, CO2. I better keep it consistent. CO2 plus H2O. It doesn't really matter what order, but just to be consistent. So, oh, you're right. Thank you. All right, here we go. I start with what number? A 2. What is 2 times 8? 16. Where does the 18 go? In front of water. 3/4 are done. Now math. 16 times 2 is plus how many more? Equals 50 divided in half. I get a 25. Combustion can be an absolute piece of cake if you follow my rules. I still have 20 seconds. Listen to me. Listen. Following my rules, my suggestions, sometimes you'll get like 2, 4, 6, 8. If they're all even, you should divide them. And then in your head, you might think, well, why do you make me start with a 2? Because it's easier. Get out of my room. Why are you still here? I don't even understand. Just kidding. I love you. I hope to see you tonight. Enjoy your weekend. I'll see you at the dance. Maybe. All right, Rebecca, I hope that went okay. That was all review, so hopefully you're chill.
Chapter 2 and 3 combined.